Good morning students. Welcome back to Sunain Sir's online classes. In this video, I am going to explain you about Human Eye and Colorful World chapter part 2. In this part 2, I am going to explain completely about eye defects in detail. Those are myopia, hypermetropia and presbyopia. So before going into the topic, first let us see what we have learnt previously. So from the previous video we have learnt that when if we place object in front of the eye, then if we place some object in front of the eye, then light rays will travel from the object through the eye, that is through cornea, aqueous humor, iris, pupil, and then finally fall on the eye lens. After falling on the eye lens will ensure that these light rays will exactly meet on retina, and exactly on the retina image formation takes place, and through the retina, whenever image forms on the retina, as soon as image forms, these one of the nerve fibers gets activated and it will transmit signal to the brain, and in the brain this signal will be processed and brain will detect the object. So this is how eye works. Now we know that from the previous videos we know that whenever object distance changes, then image distance also changes. But in our eye, so image distance is always fixed, that is image should always form on retina only then it will be transmitted to the brain. So in order to ensure that image is always formed on retina, so as the object distance changes, eye lens changes its focal length and it will see that image is always formed on retina. So this process of changing the focal length in order to ensure that image is always formed on retina, this process is called accommodation of eye. So eye lens will change its focal length to make sure that image always forms on retina. Now when eye lens is unable to change its focal length, so what happens? So when eye lens is unable to change focal length, then image will not form on retina. It will form before retina or after retina. So when image is not forming on retina, then your eye is said to have some eye defect. So these eye defects are of three types. They are myopia, hypermetropia and presbyopia. Now let us see about each eye defect detailedly in a detailed manner. First let us see myopia. Myopia is nothing but the defect in which a person can see the nearer objects clearly, whereas cannot see the far objects clearly. So if a person is able to see the near objects clearly, whereas if he is unable to see the far objects, then he is said to be suffering from myopia. So as the name is indicating that it is a near sightedness. Myopia name itself is very small, that is why it is also called as short sightedness. The name itself is very short, that is why it is short sightedness or near sightedness. Here you need to observe that this sightedness means you can see the object, near sightedness means you can see the near objects. So remember that sight means seeing, sightedness you can see the near objects, near sightedness. So in the case of myopia, image always forms before retina. So here as you can see, image will form before retina in case of myopia. Here image will form. It means signals will not be transmitted to the brain properly in order to see the object clearly. So in order to correct this defect, we need to use concave lens. One should use concave lens in order to correct this defect. Concave lens means we already know that focal length is negative. Focal length is negative for concave lens. It means when focal length is negative, power of the lens will also be negative, because power is equal to 1 by f. When f is negative, p also negative. It means power also negative. It means if you are wearing a specs of negative power, it means that you are suffering from myopia. Remember that point. If you are wearing a specs of negative power, it means that specs will have glasses with negative focal length. It means you are wearing concave lens. It means you are suffering from myopia. You are suffering from myopia. Next, so the point, we already know that till now we have seen that myopia means nearsightedness. It means if you are at this point, you can see the objects, you can see the near objects, whereas you cannot see the far objects. So for this there is one limit. That limit is called far point. It means far point is a point till where you can see the objects clearly, beyond which you cannot see the objects clearly. So remember, for myopia we will represent the point as far point. Far point means the point till where you can see the objects clearly. It means all the objects present before far point will be visible clearly, whereas all the objects present beyond far point will not be visible clearly. So this distance of far point is d. If distance of the far point is d, then focal length of the concave lens is given by f is equal to minus d. This is very important regarding 2 marks. Remember this, focal length of the concave lens is f is equal to minus d, where d is the distance of the far point. So this is the myopia diagram. So in general, if we see the object coming from far distance, light rays coming from the far distance, all these light rays will meet before retina and we cannot see this far object clearly. Whereas if we see the object present at far point means at that point or before that point, if there are any objects, you can see all these objects clearly. So if a object is present at far point or before far point, whatever the light rays coming from that object, they will meet exactly at retina and you can see the objects clearly. Whereas objects present after far point, you cannot see clearly, because all the light rays coming from objects beyond far point, they will not meet on retina, they will meet before retina and you cannot see the objects clearly. Now in order to see these objects clearly which are present beyond far point, so we will use concave lens. Concave lens will be used to correct this defect. So whatever the object is present after the far point, for example, if a object is present here after the far point, then if you use concave lens, this concave lens will converge these light rays such that they will meet on the retina and you can see the object which is present after the far point. So this diagram is very important regarding 4 marks or 8 marks. So I request you to learn this diagram, these 3 images, these 3 points very clearly, these 3 images very clearly. Now let us see hypermetropia. So the eye defect in which one can see far objects clearly, whereas one cannot see near objects clearly, is called hypermetropia. It means if a person is suffering from hypermetropia, he can see far objects very clearly, whereas he cannot see the near objects clearly. So since the name is very long, it is also called as long sightedness or far sightedness. It is also called as long sightedness or far sightedness. here you need to observe that sightedness means one can see, you can see. So far-sightedness means far objects you can see, whereas near objects you cannot see. So remember this from the name. Hypermetropia, the name itself is very long, that is why it is called long-sightedness or far-sightedness. In this case, image forms beyond retina, and correction of hypermetropia is wearing a convex lens, that is biconvex lens. So from this you can see, in this image you can see, if a person is seeing nearby object, then image of this object will form beyond retina and it will not be transmitted to the brain properly, and brain cannot process the information properly, and hence he cannot see the object clearly. The point beyond which objects can be seen clearly is called near point. So we already know that if a person is suffering from hypermetropia, so he can see the objects, far objects clearly, whereas he cannot see the near objects clearly. So for this visibility range, there is one limit called as near point. It means near point is a point till where person cannot see the objects clearly, whereas beyond which he can see the objects clearly. So near point is a point, once again, near point is a point till where person cannot see the objects clearly, whereas after which person can see the objects clearly. So this near point distance, if you take it as d, if you take the distance of the near point as d, then focal length of the convex lens which he should use is given by f is equal to 25d by d minus 25, and this is very important formula regarding solving problems. F is equal to 25d by d minus 25, and remember that here f will be always in centimeters only. In this formula, f will be always in centimeters only. So this is hypermetropia diagram. In this diagram, if you take a object which is present at near point, before near point person cannot see the objects clearly because image is forming beyond retina, whereas after near point, if you keep any object, person can see the object clearly because image is forming exactly at retina. Now if you place the object at near point, then in order to see that object clearly, image should form on retina. In order to form this image at retina, person should use the convex lens. Practice this diagram very perfectly. This is very important regarding 4 marks or 8 marks. Now let us see presbyopia. Presbyopia is a vision defect when accommodation of eye gradually decreases with age. It means as your age increases, your power of accommodating the focal length, it means your power of changing the focal length of the eye lens decreases gradually, and as a result you cannot see the objects clearly. For most of the people, near point gradually recedes. It means near point gradually changes and you cannot see, they find difficult to see the nearby objects. This happens due to gradual weakening of ciliary muscles. Ciliary muscles are the one which adjust the focal length. So as the age increases, gradually ciliary muscles gets weakened and they are unable to change the focal length of the eye lens, and as a result you will suffer from presbyopia. It means you cannot see both near objects and far objects. It is a combination of both myopia and hypermetropia. Generally this will be occurring in more aged persons, like above 60, above 50, above 55. So to correct this defect, one should use bifocal lens made up of both convex and concave lens, that is concavo-convex lens. Upper surface is made up of concave and lower surface is made up of convex lens. So one should use concavo-convex lens in order to correct presbyopia. Next, power of lens. Power of lens is reciprocal of focal length. Power is equal to 1 by f. When f is taken in meters, you need to use this formula. If you take f in centimeters, you need to use power is equal to 100 by f if you take f in centimeters. And units is diopter. Units of power is diopter. Whether you use f in meters or centimeters, it will have single unit, only one unit, that is diopter. Now let us see one example. When Harshita went to a eye specialist, doctor wrote a prescription which contains 2D lens. 2D lens means, first let us see question. What does it mean? So doctor wrote a prescription which contains 2D lens. 2D lens means here power of the lens is 2 diopter. So power of the lens is positive means power is equal to 1 by f. When power is positive, focal length is also positive. When power is negative, focal length is also negative. So here 2 diopter power means focal length is also positive. So positive focal length means it is convex lens. When she is using convex lens, it means she is suffering from hypermetropia. Now first let us find out what is focal length of the lens. So focal length of the lens is given by power is equal to 1 by f and f is equal to 1 by p, and 1 by p is given as 2 diopter, 2, 1 by 2, that is 0.5 meters. So 0.5 into 100 you will get, if you multiply with 100 you will get it in centimeters, that is 50 centimeters. Now so power is equal to 2 diopter and focal length is 50 centimeters. Since she is using positive power lens, it means she is suffering from hypermetropia. It means she can see far objects clearly, but she cannot see near objects clearly. So till where she will not see near objects clearly? So that is given by far point or near point. Sorry, that is given by near point. It means near point is the distance till where she cannot see objects clearly, whereas beyond that point she can see the objects clearly. So now we are going to find out that near point distance. We know that for hypermetropia, focal length formula is f is equal to 25 d by d minus 25. This is the formula to find near point for hypermetropia, and in this formula always you need to use f in centimeters. So f is equal to 50 centimeters is equal to 25 d by d minus 25. So here 25 ones, 25 twos. So 2 is equal to d by d minus 25. If you do cross multiplication, 2d minus 2 into 25 is 50 is equal to d. If you bring d to other side and 50 to other side, 2d minus d is equal to, if you take 50 to other side, minus 50 becomes plus 50. So d is equal to 50 centimeters. So this is the distance of near point. It means Harshita can see the objects beyond 50 centimeters. D is the distance of near point. It means Harshita can see the objects beyond 50 centimeters clearly, beyond 50 centimeters whatever the object is present she can see clearly, whereas before 50 centimeters whatever the object is present she cannot see clearly, because distance of this near point is 50 centimeters. This is the way how to solve problems. Now let us see one more example, that is find the distance till where a person cannot see clearly if he is wearing a lens of power 1.33D. So power is given as 1.33D. So power is positive means he is using a positive focal length lens. Focal length positive means he is suffering from, focal length positive means he is using convex lens. It means he is suffering from hypermetropia. So hypermetropia means till some point he cannot see the objects clearly, whereas beyond this point he can see the objects clearly. So this is the clear zone. So this is unclear zone. This is unclear zone. So this is the near point which separates both clear zone and non-clear zone, and this distance is given by D. So this is what he is asking to find in the question, distance of the near point. It means till where person cannot see the objects clearly. So in order to find that, we need to use the formula focal length f is equal to 25D by D minus 25. This is the formula to find near point for hypermetropia, 25D by D minus 25. So we need to find D. In order to find D, first we need focal length f. So in order to find focal length f, we need to use formula power is equal to 1 by f, and power is given as 1.33D. I am writing this as 4 by 3 because 4 by 3 is equal to 1.33, and P is equal to 1 by F. From this F is equal to 1 by P, 1 by 4 by 3 which is 3 by 4. So F is equal to finally 3 by 4 meters. F is equal to 3 by 4 meters. So this is, in order to use this F in formula, what you need to do? You need to substitute this F value in centimeters. We got F as 3 by 4 meters. You need to substitute it in centimeters. So F is equal to 3 by 4 meters. 1 meter is 100 centimeters. This is 75 centimeters. So F is equal to 75 is equal to 25D by D minus 25. 25 ones, 25 threes. If you do cross multiplication, 3D minus 75 is equal to D, and if you solve this equation, you will get D as 75 by 2, that is 37.5 centimeters. It means Harshita, or that person, whoever is having eye defect, that person cannot see the objects till 37.5 centimeters, whereas beyond 37.5 centimeters that person can see the objects clearly. So this is the near point distance, 37.5 centimeters. Next example, find the point till where a person can see clearly if he is using a lens of power minus 2D. Here in the question, power is given as minus 2D. Power is minus 2 diopter. Negative power means he is using a lens with negative focal length. It means he is using concave lens. Concave lens means he is suffering from myopia. Myopia means he can see the objects, near objects clearly, whereas he cannot see the far objects clearly. So that point which separates a clear and unclear zone is far point. Before the far point, person can see the objects clearly, whereas after the far point, person cannot see the objects clearly. This is non-clear zone. So we need to find this far point distance. So in order to find this far point distance, we have formula F is equal to minus D. For myopia, formula is F is equal to minus D, where F you need to take in centimeters. F always you need to take in centimeters. So in order to find F, we know that power is equal to 1 by F, and power is given as 2 is equal to 1 by F, and F is equal to 1 by 2, that is 0.5 meters, but we need F in centimeters. So F is equal to 0.5 meters. In order to get in centimeters, multiply with 100. 0.5 into 100, it is 50 centimeters. And for myopia, formula is F is equal to minus D. So D is equal to 50 centimeters. So finally D is equal to 50 centimeters. It means person can see the objects till 50 centimeters clearly. Before 50 centimeters or till 50 centimeters, person can see the objects clearly. Beyond 50 centimeters, person cannot see the objects clearly because he is suffering from myopia. Thank you for watching the video. I hope it's clear.